So hello student, last class we have discussed the classification of instrument. In that we have discussed the analog instrument classification and about this. In this class we will discuss about the digital instrument. Digital instrument. So first we should know what is the digital instrument. The digital instrument converts the measured quantity may be pressure, temperature, flow level into numerical values, which is and displayed in it digit. Usually for displaying we can use LCD liquid crystal display or LED light emitting diode. It is easy. The second thing is that digital instruments offer very high accuracy and easy of reading rather than analog instrument. So next thing, what is the digital instrument block diagram, and we will discuss about each and every component of block diagram of digital instrument. First is the physical quantity to be measured. So that physical quantity may be, in this physical quantity may be temperature, physical quantity may be temperature, pressure, flow, level, anything can be physical quantity. That physical quantity to convert into electrical signal. This is the electrical signal by using the sensor transducers. During this conversion, different type of signal conditioner can be used if the signal is very less amplitude wise. So we have to amplify the signal using pre-amplifiers. If the noise is also included in the output of that transducers, so we can use the filter to removing the noise. After getting the analog output, we have to add the ADC, analog to digital converter, which convert the analog signal into digital signal. Because why we are converting analog to digital? Because for calculation we can use the microprocessor and microcontroller for analyzing that signals. So and again we are providing this signal modifier. So what is the which element is used in signal? So this is the, here can be used the microcontroller, microprocessor, we can use microcontroller. Second, after microcontroller, and then we can use the digital display unit for displaying the signals. So how is the working principle of digital instrument? So first the quantity will be used to measure the temperature, pressure. Second thing is signal sensing. Which element used to signal sensing? A sensor or transducer detect the physical quantity and change into the analog process. Second, analog to digital conversion, that analog signal is converted into digital signals. And third is a process in signal modifying and processing. Yes, signal processing is done here. Signal SGP, signal processing is done here. Digital signal is processed by microcontroller. For we can use for processing microcontroller and microprocessor for calculation. And last is the digital display values, for we can use the numeric display in numeric form. Different type of digital instruments we will discuss. First, electrical measuring instrument, digital multimeter. To measure the voltage, current, resistance, and other electrical parameters. Digital instruments we can measure electrical resistance. The question generally which may be asked, which The analog, sorry, digital multimeter can be used for measurement for voltage, current, resistance, and other electrical measurement. We can use the digital. Other digital voltmeter measure the electrical potential difference across the 2 points. For digital ammeter for measurement the current in circuit, then digital power meter to measure the power consumption AC or DC. Next is the thermal measuring instrument. Thermal measuring instrument may be digital thermometer to measure the temperature using like thermistor, thermocouple. Second is the infrared thermometer. So infrared thermometer measure the temperature from the thermal radiation. How it is measuring? In infrared radiation, thermocouple measure the temperature of object by focusing infrared radiation on a detector which convert electrical signal into the electrical signal. The thermometer then use this signal to calculate the temperature object. So first it is how it will look. So first this is the example of infrared thermometer. It look like this. Here probe is there. This is the display. Display backlighting, different up and down keys, different function keys, and battery storage is there. A streamline handle is there. Measuring key is there. Different. This is how it work. This is we can see the working of the digital infrared sensors. Suppose what objective is this? Suppose this is here. What objective means any object which is creating a radiation. So what object is there? So we can use first focusing, a focusing lens, so that the lens can focus into one places. And before that we can use the filter. Filter is used. Filter only pass the infrared radiation. Other radiation is not passing from here. And then this radiation goes to the infrared detector, which converts the infrared radiation into electrical signal using different type of electronics. Suppose that infrared radiation is there, and use the temperature indicator to indicate on this. Here different electrons, different type of functioning like this. Suppose that here infrared it creates the electrical form signal. Suppose here input is output is a form of electrical signal. Then this electrical signal we can use here different type analog to digital converter, microprocessor, and signal conditioning, so that we can change the digital display recording into digital signal and display. So in this electronic circuit, so many components we can use. Suppose that infrared, this is the infrared sensor, IR sensor output is a electrical form, double signal. Then we can use here one A to DC, analog to digital converter. Then we can microcontroller or microprocessor. And after that, we can use the digital display recorder. In this way, process can be done using the digital infrared sensor. Another the pressure and flow instrument like digital pressure gauge. How it look like? So you can see this is the digital pressure gauge diagram. It will look like this. Pressure we can apply from here, and reading we can show on the display. So digital pressure gauge measure the fluid or gas pressure with high accuracy. It measures the fluid or pressure gas with high accuracy. Digital pressure gauge uses pressure sensor to convert pressure into electrical signal, which means they displayed on a digital screen. So generally piezoresistive pressure sensor is used mostly frequently due to their robust design and lower prices than capacitive sensor. So digital pressures we can design two ways. Pehla, Piezoresistive material, we can use piezoresistive material, and second thing we can use the capacitor. But resistive material generally used because of their low cost. And next we will discuss this it look like. Next, the flow meter measure the flow rate in pipeline, so such as ultrasonic or electromagnetic flow meter we can use. Time and frequency measuring instrument are digital stop to measure the time interval with high precision. Frequency counter we can also use to measure the frequency of period of signals. Another digital instrument can be oscilloscope. Digital oscilloscope look like this. Here waveform is this, we can measure it from this instrument. Time period, frequency, amplitude, we can comparison different types, so many signal analysis we can use in this, the digital oscilloscope. Digital oscilloscope look like this. Next is the spectrum analysis. This is also digital instrument. Analyze the frequency spectrum of the signals. Means how the signal frequency look, this spectrum, this look like this, or this like this. Any type of frequency spectrum analysis can be done through the spectrum analyzer. Spectrum analyzer is a real-time instrument. For example, it simultaneously display on CRT the harmonic peak value versus all wave component of frequency range can be analyzed. So this look the spectrum analyzer look like this. We can use the for analysis of frequency spectrum of the signals. Different type of the smart devices we can use, like smart watch, digital weighing scale, fitness tracker provide accurate measurement. Additional feature. Difference between the analog and digital instruments. This is we have discussed our previous class different type of analog instrument. Right now we have discussed different type of digital instruments. So then right now we will give the comparison or difference between the analog and digital instrument. First we will comparison based on the display. So analog instrument is a continuous scale, pointer or dial. Means analog instrument, this is its output is form of continue, then we can show on any dial or by the pointer like this analog. But in digital instrument, digital instrument numeric readout is there. Digital or numerical readout is there. Here only we can see the digital 1 1 0 1 0 like this we can read out. Second, accuracy. The accuracy is limited by scale resolution in case of analog instrument, but digital instruments are more high accurate and precision. So for discussing this point, we should know what is the accuracy and precision. So definition of accuracy, it is the degree of closeness between the true value and measured value. Suppose that this is the true value, this is the measured value. So how these values are close to each other, this is the accuracy. Which instruments give the more and more close value to the true value, so that instrument may be will be more accurate than compared to another instrument. So in case digital instrument gives the more and more accurate value near to the actual value, so that's why digital instruments are more accurate than compared to analog instrument. So, and second point, the accuracy of the analog instrument is limited by scale resolution. How the analog in this instrument accuracy is limited by scale resolution means analog output in form of is we give the analog form reading. So what is the real minimum detectable output for that instrument can respond for that value? Suppose that any instrument is responding 5.1, 5.2, 5.3. For this instrument is recording like 5.3. But if we increase this value from 1.12, so this analog instrument is not responding for that value. So because of this scale is not detectable, displaying this small changes. That's why its accuracy is limited. But in digital instrument, this can be detected. So this is the scale resolution limited by the accuracy. Accuracy is limited by scale resolution. This is the point we are discussing. Right now, this is a noise resistance. So analog instrument susceptible to more noise and interferences, but digital instrument are to resist the noise, more resistance to noise. Reading, analog instrument required interpretation by the eyes, but digital instrument direct numerical reading is there. Complexity simple design. Digital instrument more complex and expensive. Cost, third is a cost. They are analog instrument typically less expensive and digital instruments are more expensive and more costly. So this is the main point of. So we will discuss first digital and analog instrument. We can summarize like this in terms of accuracy very high. This accuracy is very high in case of digital instrument. Analog accuracy is limited by the scale resolution. Cost high, cost analog is low, and simple analog instrument simple and construction very easy. Different type. And then now second topic we will discuss about the self-generating instrument. What is self-generating? This type instrument comes under this category. We will discuss this. So these instruments generate on their energy, usually electrical signals, to make the measurement. They typically don't require external power source to operate, making them highly efficient for certain application. So there is no need to operate. There is no need to give the external power supply to operate the instrument and produce the output. So such type instrument or the, for example, in this category, which instrument is come like thermocouple. In this category, thermocouples comes TH. Thermocouples. Strain gauge also comes this category. Strain gauge STG. Strain gauge also comes this category. And there is a piezoelectric materials PZ also comes in this category. So three types of instrument generally comes. We will discuss. So the same definition is in instrument that convert physical quantity, temperature, pressure, force directly into electrical signal without need any external power supply. So that we have discussed this point. Type of self-generating instrument. Thus thermocouple. So we have discussed the example thermocouple. Thermocouple is convert the temperature difference into voltages. So used in temperature measurement. So this is a thermocouple. A thermocouple has two junctions. First is a hot junction, second a cold junction. And for there we can use different metal. We have to use the different metal here, and here we can take the voltages. So we will discuss before. This is the diagram. This is the thermocouple diagram. Suppose that this is the thermocouple. This is the thermocouple. This is the T1, T2. This is the temperature T2. This is the temperature T1. temperature change. This is the metal A. Condition is this metal A. This is the metal. We have to use different metals. When two dissimilar metal are, definition of this, when two dissimilar metal are connected here and two different junctions T1 and T2, so it creates this junction. This is the hot junction, this is the cold junction. So it creates the voltage is proportional to the temperature differences. So this is the working of how it will work to create the temperature differences. Means the output voltage we can write S into delta T, temperature differences. So the delta T is the difference between the hot junction and cold junction. As the sensitivity of the thermocouple is depend on the which materials we have used. For different type of material we can use. This is the chromel and alumel. So they have different differences. Copper and chromium, they have different sensitivity. So if the material are changed, then sensitivity will change. So this we can in this way it can generate the output. It range generally millivolt ranges. So for temperature measuring ranges. So for selecting we can use the different materials for different temperature ranges. And when we will discuss this when we will study the industrial instrument in detail. Second is a piezoelectric sensor. It converts the mechanical force, stress or pressure into the electrical charges when like we apply the pressure or vibration on sensor. This is the diagram of piezoelectric sensor. This is the piezoelectric. This is the thickness. T is the thickness. W is the width. Here this output terminal is there. When force applied on here to this structure, it deforms. Suppose that this is the piezoelectric crystal. We are see here. When the force or stress is applied on it, this is the output force or so it starts to deforms. Material start to deforms, and because of so it creates the charge on it. Creates the charge on it, and that charge we can convert the voltage, the function of force applied. So because material deforms, because of deformation, it creates the charge across it. Then that charge we will convert into the voltage. This is the function mainly of piezoelectric crystals. So this is the diagram how the voltage is generated. Next, strain gauge. Measure the strain in material and convert into the electrical signal used in load, cell or force measurement. This is the diagram strain gauge. First we will fill the diagram of this. This is the strain gauge. This is the strain gauge wire. Suppose that is within the material. We look. This is the material. This is the backing, gauge backing. This is provided. This is the gauge backing. Look like this. Gauge backing, and here this is the different wire arrangement of this like this, and here we are taking the change in electrical signal, and then output here it like this. Strain is applied on this or this direction when, and this output we can give to Wheatstone bridge. This is to give to any Wheatstone bridge, like give to Wheatstone bridge, like here we can see the Wheatstone bridge. Second thing is there you are using like so. This is force if this is applying on single arms of Wheatstone bridge, that is the quarter bridge. If this arrangement can be used for two arms of the bridge, then that will be the half bridge. if this arrangement all arms of bridge, then this will be the full bridge strain gauge. So we will see how this strain gauge work. So strain gauge, this is the strain gauge material like this. When force oblique stress is applied on here, so it creates the voltage. What is the strain? First we should create the strain. So strain is nothing but change in length via original length in dimension. Suppose that this is b, because we are applying on this, suppose that we apply, so its dimension look like this. This is the new dimension. So this is the change in dimension. So delta L upon original length, this is the strain. This is the definition of strain. Strain is nothing but change in length, del L divided by original length. This is the strain. So when we apply the force on a strain gauge material, so it deforms. Because of it deforms, length changed. Because length change, strain is del I by strain is changed. Due to creation of the strains, its resistance will changes. Its resistance will changes. So in this way we can measure the electrical output. There is no need to external power. There is no need to external power for this, because this is the strain gauge material. Force, this is the force or strain is applied on here. So it creates the delta L strain. Because of this strain, so this resistance is changes. So how using this formula we can decide the gauge factor looking like this. The gauge factor of this is the delta L by L strain upon delta R by R, delta R upon R. So if using this for this is the depend on the which materials we have used. For semiconductor it ranges approximately 150 minus 150 to 200. For metal it is around 15.22. So it can be different for different materials. In this way we can measure the strain gauge. Always application industrial process control for load measurement. For suppose that this is the tank, so how the industrial control unit can be used. Suppose that this is the tank, we want to measure the weight of this tank. So we can use the strain gauge here. For environmental monitoring, temperature, pressure control, we can use structural health, we can use. There is no need to external power sources, because strain is applied. So because of deformation, strain created, and that because of strain, resistance will changes, and that's we can measure at this with high radiability and high use a direct conversion physical quantity to electrical quantity. And next is a power operated instrument. The power operated instrument required an external source of power like electricity or compressed air to operate them. These instruments typically involve more complex systems and can offer enhanced features like amplification, signal processing. All things are there. Power operated instrument. The instrument that depend on the external power supply to measure, control and manipulate the physical. Just previous we have discussed the self-operated instrument. These instruments don't require any external power to operate them, but power generated instrument required power to operate them. Third type of power generated is electromechanical instrument. Instrument like electric meter, relays, control valves, all these instruments require power to operation them. Second type is pneumatic and hydraulic instrument. The instrument that use the compressed air or fluid to operate a mechanical element such as actuator, sensors, electromagnet. This is a digital instrument, the instrument that use the digital signal processing required to external power like digital thermometer, oscilloscope. So these are the application automation and control system. Factories, industries may generally use advantage high precision and high accuracy. And second, the ability to produce a display record. One time we can discuss about what the precision. We have discussed the accuracy, but what is the precision? We can also discuss precision. Precision is nothing but the degree of close. We can say also degree of closeness between the measured value. If which instrument degree of closeness between the what? How much reading are close to each other measured by an instrument. Like suppose the precision means measured. Suppose that two instruments. We can see that by example. Suppose that this instrument 1, this is the instrument 2. Suppose one instrument measuring 1.4, we are measuring 5 ampere. Suppose one instrument measuring 1.5, 2.5, 2.3 as a 1.5. This is the one instrument. The second instrument reading like 5.1, 5.11, 5.111, like this. And so this means this instrument is more precise because its measured value are more close to each other. In case of accuracy, the reading must be more close to true value. But in case of precision, the measured value more and more close to each other. So this is the main difference between them. That's why we always say every accurate instrument will be precise, but it is not necessary every precise instrument will be accurate. So this we have discussed that precision. Precision means degree of closeness between the measured value. Measured value how are close to each other. This is the precision. Ability to process display. Correct. So right now we can comparison between the self-generating and power-generating instrument. This is the power-generating instrument we have discussed. Next we will discuss the self-generating. Based on the power, self-generating instrument don't require external power, but power-operated instrument they require the external power. Example: thermocouple, piezoelectric sensor, strain gauge are the self-generating instrument, but controller, digital pressure meter, oscilloscope, these are the power generated instrument. Complexity: self-generated are simple and direct conversion. Power generated instruments are more complex, including different type of processing and control. Application: to measure remote areas, power scarce environment where we don't have a power. So that places we can use the self-generating instrument. High precision and control automation industries are very precise, very close, very controllable output we need. That places we can use the power operated instrument. Advantage: energy efficient, reliable, high performance is required. Next we will discuss about the contacting instrument. These instruments require direct physical contact with medium they are measuring or controlling. They are typically interact with the process and material environment. For example, for measuring the physical parameter like pressure, temperature, flow, level, that so they can direct contact with physical quantity to be measured. Such type of instrument is called it contact instrument. For example, thermocouple. For temperature measuring, the thermocouple direct contact with. So this is the direct contact with the look like this. This is a direct contact. So this is an example of thermocouple used to temperature measure. They are two different like pressure gauges. This is the pressure gauges. This is also the mechanical devices that convert the pressure by direct contact with the fluid. Suppose that so direct. This is the suppose we have pressure applied from here because this is the Burton tube because of this pressure applied here. So this converted to pressure to displacement. This is the beauty of this pressure to this convert displacement pressure to displacement. So this is the pointer and this end is deflecting and this deflection recorded on the pointer. So this instrument look like this. We are applying pressure from here because the Burton tube displaced here. So this deflection see on the diameter. Different of component Burton tube, connecting rod, connecting, and this is the pinch, power, source of stresses. We can use this. And then another strain gauge. Strain gauge is also used to measure the strain or deformation in a material by direct physical contact. So we have discussed in the previous class the strain gauge used to measure the strain deformation. Like this is how the physical contact is this. This is the suppose this is the strain gauge. Strain apply on it like this. So here direct contact, strain apply on this stop or pressing. So direct this that's why this comes under the direct contact instrument. Flow meter, different process, rotameter. These instruments involve direct contact with the fluid because fluid is flow from here. Fluid is flow from here and going like this out. So this is direct contact. This is the rotameter look like this. This is the tube. This tube is a form of tapered, means this outside area is more than compared to inside. This is the float. Float is a balance when this pressure and here the applied pressure on it is balanced with the. So this work on the balancing of. Now use the buoyancy forces. So this is the inside layer of rotameter look like this. This whole flow management we will discuss in detail in industrial instrumentation, each and every instrument. We should know here only know how instrument look like, in which category this instrument will come. High accuracy, bail and established is there. And second is a non-conducting instrument. Non-conducting instrument don't contact with physical quantity. Previously which instrument they are contacted directly with physical quantity, but these instruments don't contact with medium. Without contacting the direct, they are measuring the quantity. For example, infrared digital thermometer measure the temperature. We have discussed this instrument previously how it will work. It measures the temperature by detecting infrared radiation emitted by without making contact. Laser displacement sensor measure the distance or difference by using a laser beam without contacting. Ultrasonic flow meter use the sound wave to measure the velocity of fluid without through pipe. So this is the instrument. This is the ultrasonic they are put it here outside the pipe. These two instruments are put it only because one instrument is put here outside the instrument. They are not contacted with the fluid. Fluid is flowing actually here. That's why fluid is flowing. They are fitted. This is the pipe. They are fitted on this pipe. They are fitting on this pipe, so they don't contact to the fluid. So that's why they come under the non-contact. And how will they work? We can see the roughly very short when we will discuss the flow meter in detail. Then we will just work on this. Ultrasonic flow measures the velocity of fluid by sending a sound wave through it and measure the time taking through for sound wave to travel that flow rate is calculated by measuring the time difference between the sound waves and traveling opposite direction. Suppose that this is the in this instrument fluid is flowing like here from here, that in this way fluid is flowing from here, in fluid is flowing flow here. This is the one transducer. This piezoelectric sensor is there here. It sends some waves like go through it, and again it receives the signals again, and then again it sends the signals again to so this instrument, they can be receive the signal and transfer the signals. They have so both function the instrument can. Generally piezoelectric sensors there. One time it can act as a receiver, and same another time it can act as a transmitter. Here generally piezoelectric material is used. So it pressure of force applied from outside this is, it generates the waves from a burst, then it waves go like the current, and again when this wave strike on this material, it creates the receive it and create the voltage, because piezoelectric material. In this way we can use this instrument. Second is a radar level transmitter, to measure the level of material by bouncing the radio waves and it to detecting the signals. Dumb instruments are basic measuring devices that don't process or interact with the data themselves. They simply collect and display the measured value. It is raw. It usually required interpretation reading manually. So different type of instrument we can discuss right now. This is the analog thermometer. This is the dumb type instrument. Means the display the temperature directly but don't record the process data. Means only thermometer, if you put inside the any temperature measuring instrument, you touch with temperature measuring instruments, this is the mercury, this is the like when liquid is there, so according to temperature this liquid reading change, there is no any recording is there, dumb. Only just for the reading, no recording, no processing, no nothing is here, the less advanced thing is there. So only directly, don't record any process, nothing, only so that this is digital. Manometer, this is the manometer used to fluid pressure, measure the fluid pressure with the reading displayed on a scale. Here reading, so this working very simple here. This is the YouTube manometer. The pressure is applied on here. The pressure is applied on here, and so initially they are in the atmosphere. Initial level is same, and the pressure is applied. So this here the level is fluid filled here is down, and here increased. So we can measure this distance. We can use by the scale, and so and we can change the different. We can measure the differential pressure. Delta rho GH. Rho is the density of fluid filled here. This is the rho. This is the G is at 9.8 meter per second. Height we can measure here in this way. Change in differential pressure that can be used to measure and display on the screen. This is the height. Same mechanical dial gauges that measure the displacement or channel through the position. Characteristics: no data processing here. Simple and simple display mechanism. It requires manual intervention to detect and analyzing. And last is the we will discuss the intelligent instrument. We have discussed the just previous dumb instruments. They are not intelligent instruments. They measure and display. They don't record, don't process anything. They don't do. Only they the process the result. In this section, we will discuss the intelligent instrument. The intelligent instrument are advanced devices that not only measure but also process the data internally. Here data processing is here. So this is the data processing, but data processing is not done in the dumb instrument previously. Internally, often they involve in microprocessor software to perform complex function. Instrument can display, proceed data, and store even the transferred further analysis. So that's why they are called a smart instrument. So some component we can see that sensor, sense the physical quantity, temperature, and external. The signal conditioning, you suppose that output of sensor is very small for the analysis that signal cannot be. If the noise may be involved here, so we can use the filter in signal conditioning. In analog to digital converter is there for processing. Then microprocessor for calculation, and modem can be used here. Digital to analog conversion. Power supply can be so many different component we can see here. Microcontroller, modem, analog to digital, and digital to analog, different double EPU electrical erasable program, calendar or memory, they have different. So don't memorize that diagram, only we should how such type component comes under the digital instrument. For example, digital instruments is digital thermometer with data logging to measure the temperature and store the historical, providing both real time and logged output. Second, pressure transmitter instrument, level transmitter, different type of instrument, level transmitter instrument, pressure transmitter instrument, temperature transmitter, different type instrument and transmitter instrument. जो smart transmitter like smart transmitter, smart pressure transmitter, smart level transmitter, smart temperature transmitter instrument comes under this category. So so we will see the diagram of such type of smart transmitters, which element is these instrument convert, because this is very important for instrumentation. So these instrument concept like microprocessor, memories, communication devices, analog to digital converter, digital to analog, both type of converter. First input, the sensor may be also integrated with the smart transmitter, and the input either received from integrated sensor or externally we can see. Then again input comes, then analog output of the sensor data transfer may be form of analog, that we have to convert analog to digital, because the for processing calculation we need to digital signal, because our microprocessor or microcontroller generally they understand the analog, not analog but digital format 0 and 1 for a second. Then we have to convert analog to digital and process. This is the complete unit which communication devices and memory. After that again we need to convert that output of microprocessor in form of digital. So then again we need to digital to analog converter, because output we want to display in form of analog, because in industry generally we are transferred the signal from one location to another using 4 to 20 milliamperes, because this signal loss is very less. A standard output 4 to 20 million. The output of also come in form of digital pulse, foundation, field bus, Profibus, wireless, hard. Depend on the hard is a high addressable remote transducers, and we will discuss the industrial instruments. We will see the detail in that hard and pressure transmitter, different type of smart transmitter. We will discuss this. This is the general introductions. Characteristics: automatic data processing and interpretation, often include the data storage and retrieval features. They can interface with other systems, remote monitoring, control. And last, we will compare the difference between the dumb and intelligent instrument. Dumb instrument or intelligent data processing. So dumb instruments, they don't need to any processing in data, but intelligent instrument internal data processing is done. Complexity: simple and basic. Dumb instruments are simple and basic, but intelligent instruments are very complex but integrity. We got different type of microprocessor, microcontroller, communication devices, memories are required for processing the data. Dumb instrument required manual interpretation, but intelligent instrument required minimum user intervention. Cost: dumb instruments are low cost, intelligent instruments are higher cost. Example: analog for dumb instrument, analog thermometer, gauges. Intelligent sensor, smart sensor, pressure sensor, CNC, differential pressure transmitter, smart pressure transmitters, temperature pressure transmitters. These are the intelligent instrument. Applications: basic measurement. Dumb instruments generally used for basic measurements. Intelligent instruments are automated systems recording process rate. So today is our first module, sensor and transducers का complete. Sensor and transducer is completed. This is the last class of sensor and transducers. In next class we will discuss about our module second. So this is the our first module is completed in this class. Thank you so much.